Hello, Wizardry subscribers. This is the July 2011 issue of Reason Wizardry. So since last month, we've had the bombshell announcement of Reason 6. So Reason 6 is on its way, and you've probably read about its upcoming features and new devices. And of course, we're going to be going through those new devices and features in detail once Reason 6 is available to the general public. But in the meantime, what I wanted to do in this issue is specifically look at one device, the Pulveriser, and I want to create something using the Combinator and individual Reason devices to create something like, let's say, a Reason 5 Pulveriser. The goal of this isn't to necessarily build a device that will replace the Pulveriser, but it's more instructive in seeing an effect device and then being able to translate that into a Combinator. So you could use that for anything. I've personally used this same technique to recreate some hardware effects in our Filter Research 2 refill. So the end goal is more to demonstrate this type of effect creation and to give you a pretty cool and usable compression device using the Combinator. We're going to start by looking at what the Pulveriser offers so that we can start to get an idea of how we're going to build a similar device inside a Combinator. The Pulveriser starts out with the squash and dirt controls, and it's also got a filter, and modulations can be created using either an envelope follower or the tremor, which is essentially a very high-speed LFO. So it isn't a completely set signal path. You can configure whether the compression happens before or after the filter. And finally, there's a wet-dry control at the end of the effect signal path that allows you to mix back in some of the dry signal if that's what you want. So we're going to start out by creating the compression effect. I've got a drum loop already loaded that we're going to use to preview this effect. So let's get started with the compression. We're going to actually use two different compressors. We're going to use the M-class compressor, and I'm going to use the Scream 4. Set to its tape compression algorithm. Now what we need to do is split the audio signal so that it's going to go through both compressors. So we'll take the two devices feed and we'll send that into both the M-class and the Scream 4. And now we'll create a mixer to send both of the compression outputs. Okay, now we just need to make sure that the master out is connected to the from devices, and it is. So we should be able to hear our compression effect. So that's a pretty typical tape compression sound. And we can bypass that and listen to the M-class, which right now isn't active at all. The signal isn't loud enough. We'll give it a bit of input gain here. Okay, I'm just trying to equalize their volumes somewhat right there. Okay, so now we have to decide how we want to use these two compressors. My thought is that they could be switched between using one of the combinator buttons. And now this is kind of going beyond what the Pulveriser offers. Obviously, there's just one type of compression. But of course, we have freedom to add a little bit of something different since we're creating this device from scratch. So why not? I think it's nice to have two different flavors of compression. So let's set this as comp type. And then we will automate the mixer channels with button 1. Button 1 will set the first mixer channel to 100. And then we'll just do an opposite modulation for channel 2. So you can see when we push this button, and now we can also hear it. Okay, so that's pretty cool. Let's move on and create a rotary control for the amount of compression. And we'll call that squash to follow the naming of the pulverizer. And we'll add a modulation for that for both of the compressors. For the scream, it's pretty easy. Parameter 2 here is compression, so we can just use rotary 1 going to parameter 2. And it's a little bit more complicated for our M-class compressor because it's got a threshold, input gain, and the ratio. So we're going to need to map something that changes multiple controls at once in order to have kind of a one rotary control over the amount of compression from this M class. So we'll want ratio to start at the very lowest and then move up. At a minimum, we need that. So if we set it to 100 at a max, it's going to go up to 16. I think that's probably enough. So we'll keep that as the max. And threshold, we're going to want that to start at 0 dB, which means there's no compression happening. And it will be turned down at the same time the ratio is being turned up. So let's set rotary 1 to the threshold, starting at 127, and then we'll say, we'll try 30 and see where that ends up. Okay, a little bit lower than that. All right, I think that works. And for the attack and release, this is something that the Pulveriser doesn't expose to the user. I have a feeling that it modifies the attack depending on where the squash rotary is on the Pulveriser, but I'm not exactly sure how it does it. It does have a separate release control, but we have a limited amount of rotaries here, and we need some other controls for the filter and for the distortion or dirt that we're going to add as well. So I'm going to just set the release to adapt instead of mapping one of the controls to it. and I'm going to set the attack at 10 milliseconds, and that can always be changed for different applications, but I think that'll work as a starting point. I'm also going to leave the input gain turned up, but again, that might require some tweaking depending on what sound is running through the combinator. So now let's hear what that sounds like with our drum loop. You can see that's some major compression happening right there. And now we can switch back over to the Scream 4. One of the problems is that as the compression is turned down on the Scream 4, the volume gets somewhat louder. So I think we should introduce another modulation to control that. And let's just do that right now by setting Rotary 1 to the master volume level, which is currently set at 85. Well, actually we want it at 85 when compression is full, and then we want it slightly lower. Let's try 70 when compression is totally off. It's still a little bit loud. Let's try 60. Okay, I think that works. I'm getting the feeling, though, that perhaps the tape compression isn't quite as intense an effect as I'm hoping for, because certainly the Pulveriser that we're attempting to emulate is a very intense effect when turned all the way up. So I'm going to increase the damage control here. Yeah, I'm liking that more. You can hear how the tape compression actually still has an effect when turned down to nothing, almost adds some distortion to the sound. Okay, I have a feeling that by changing that damage control, we no longer have the right volume balance between these two compression channels. Actually, it looks good. Let's just hear how it sounds. I think we could have a little bit higher output gain right here when full compression is happening. So let's go back once again, go to Rotary 1 and set the output gain. Normally it's set, probably, it's tough with some of these controls that this is set in dB. So we have to kind of guess what value that turns out to be on the 127 step scale. So probably around 63, and we'll turn it up, let's say to 75. I'm still thinking it's a little bit not loud enough. Let's try 85. I think that's fairly close, so we'll stick with that. All right, so we're just getting started, but we've already made significant progress creating a kind of interesting dual compression effect here that's going to be the start of our Pulveriser-esque combinator. All right, so the next thing in our signal chain that we need to add to create our Pulveriser-esque effect is dirt or distortion. And of course, we could use many different things. I think I'm going to continue on with the idea of having two different types of effect, like we've done with the compression, and we'll use two different types of distortion. So let's bring in Scream 4 here, and let's minimize the compression section just so we can easily focus on what we're doing now. And we'll take the master output from the mixer and send that into our distortion Scream 4. And then we'll take the output and send it to the from devices. So what I'm thinking is that we'll use two distortions here, one more standard and one more extreme. So we'll have the tube distortion and the scream distortion. So we'll set this up on button 2 as dirt type. And we'll create the modulation. Go for damage type here. And I believe 9 should be scream. Just had the wrong button mapped there. Let's see here. Yes, 9 is scream. So, and it starts at 0. So 0, 1, 2, 3 is tube. So we've got that modulation set. Let's hear what it sounds like when we run our drum loop through it. And for this effect, we're going to just set the P1 and P2 values to something usable and leave it there. Once again, we don't have many rotaries to work with here. So we're going to just set them at something, and you could always go in and change them, but they're not going to have specific combinator controls for that. So let's change the dirt type. That's not really as dirty as I'd actually want it. Okay, that's not bad. We'll go with that. So now the trouble with creating a single knob or rotary that's going to accomplish what this dirt rotary accomplishes is that the damage control on Scream 4 is kind of weird. It's almost a volume control as well. So you're not able to just dial in the amount of drive while the volume stays constant. And I'll play the drum loop back again and you'll hear what I mean. So I don't think it's really that useful to just have a drive knob mapped right to the damage control because it controls volume so much, and I'd rather just control the amount of distortion specifically. So to do that, we're once again going to need to create a modulation that changes two different rotaries at once. So we're going to need to control the damage control and the master volume here. So we'll use rotary 2, and we'll set up the damage control here from 0 to, we'll say 85. should be enough drive. And then also the master level. So when the damage is completely turned up, we'll have the master control set to around 60. And when it's completely turned down, we're going to need a whole lot more volume than that to compensate for the lack of drive. So we'll try 100. Let's hear how that sounds. Okay, we're going to need just a little bit more range than that. Let's say we'll move that down to 55 and this up to 105. Just about there. Let's try 115. Okay, that's definitely not bad. 127 and 50. So we'll just label that as dirt. And so now we've got our distortion, our dirt, added to our combinator. And we'll move on in the next chapter with setting up the filter. Okay, so what we need next is a filter. So for that, I'm going to use a Thor. So let's add that in and add it after the Scream 4, the Distortion Scream 4, that is. All right, so now let's set up its audio inputs to be sent to filter 3. And as for filter 3, let's add a state variable filter. And now let's map some controls for it. Well, actually, first let's make sure it's working and turn on our loop here. Okay, it's working fine. So now we need to map some of its controls to our rotaries. And we have 2 rotaries left here. And that's a little bit of a problem because I want to map more than 2 parameters for this filter. I'd like filter frequency, filter resonance, and I'd like a rotary to control the filter type, because I don't think it's enough to just scroll through 2 different types using a button. So let's make that happen by starting with filter type up here. So we'll go with rotary 3, going to filter 3, and we want state variable mode. And yeah, it's scrolling off screen. I can't quite fit all of that in, but it is working. Now, the reason that I put the filter type up here is because we have to use a combinator modulation for that. I'm planning on putting the filter frequency and resonance here, and in the mod matrix, there isn't any way to control the state variable mode. So So instead, we use the combinator rotary for that, and then make use of these for frequency and resonance. So we'll add that in now. Modifiers rotary 1 and 2. We'll send them to filter 3 frequency and filter 3 resonance. All right. Okay, so now I'm going to move this Thor to the top, even though that's not really true in terms of how the signal path is generally going from top to bottom. It's just easier to control when you open up the combinator. I like to have my Thors with controllable features in a big, perhaps complicated combinator like this. I like them to be near the top. So now for button 3, I'd like to add even some more configurability to the Thor filter, and I'm going to add, we'll call it ladder, and what that's going to do is switch between the state variable filter and the ladder low pass. So we'll just get button 3 here, going to filter 3 type, and I believe ladder is 0 and state variable should be 1. So I think that should work for us. Yes. And of course, filter type, once you've switched to the ladder, it should also do something. And currently it doesn't, because it's just mapped to state variable mode. And so we can map it as well to filter 3 ladder slope. So now we can move through the slopes and we can move through the modes. All right, so we've got all the major elements for our combinator now: compression, distortion, and filtering. Now we need to look at adding some modulators. And obviously, the first one that comes to mind from Pulveriser is tremor, which is the special LFO that can do filter FM as well as amplitude modulation. So we're going to add that here in our Thor by adding LFO1 and sending that to filter 3 frequency FM. And now let's play back our drum loop. And you'll notice that there's no LFO action happening right now. And that's because LFO1 is a voice level modulator, and that means we need to trigger Thor in order to hear its effect. So the easiest way to do that is to use the step sequencer. So let's change the step sequencer to 2 steps, and let's increase the gate length of those steps to 100%. Turn the sequencer on repeat, and essentially we'll be continuously triggering a never-ending note from this LFO. So let's hear that. So it's definitely working now. So we need some controls for it, and we're running low on controls right now. We've already got these rotaries used, and we've only got one rotary left here. So instead, what I'm going to do is create another Thor. And we'll be able to use its rotaries to control the LFO. So we want LFO depth, and we want LFO speed. So now we're going to send out signals from these rotaries to the first Thor. So we'll take rotary 1, going to CV output 1, rotary 2, going to CV output 2. And we'll send those signals here. And we're all linked up. So now for the LFO depth, all we need to do is scale this by CV input 1, which is coming from here, remember. And for LFO speed, we'll take CV input 2 and send that to LFO 1 rate. So now let's go back and hear what it sounds like. So that's definitely working, but actually there is a pretty low maximum rate right now. And sometimes you'll find in Reason that you'll need to actually send more than 100 to a destination in order to get a wider range. Sometimes you don't need to do that and 100 is enough. But in this case, this LFO can get much faster and it'll actually be pushed into audio rate levels, and that's where we'll get filter FM from. So let's add a second LFO 1 rate and turn it up. So I'm not too sure if that's actually the maximum yet. So I'm going to add a second line and just continue on adding to this LFO 1 rate until I can't hear any more changes at the top end of this range. And that seems to be it right there. So now we have the full range of LFO 1's rate all the way from 0.07 hertz to, well, I'm not sure. It's really high though. So let's listen to that. Okay, so we've got a really usable LFO there. We've got configurable depth and configurable speed. So that's certainly not going to match all the features of tremor. You'll notice in particular there is no amplitude modulation from this LFO, which is one of the interesting features in tremor. I haven't found a way to do that in the Reason environment using separate devices that sounds good enough to really add to a combinator like this. So if you can't do it really well and with good sound quality, I don't think it's worth doing. Okay, so we've taken care of tremor. Now the other modulator is an envelope follower. And I think it's pretty awesome that we're going to have easy access to an envelope follower in Reason 6. But I have been creating, you might say, wannabe envelope followers using different devices in Reason for a couple of years now. I believe in May 2010, we originally talked about envelope followers in depth. And I also think I touched on it last month as well. So what I've actually done is copied an envelope follower from last month's episode into our project here. And it consists of two devices, the M-class compressor and this Thor right here. And I'm not going to go through how it works exactly again. I think most of you have got some idea of that in previous issues. If you have questions about it specifically, feel free to email me. But basically, what we're going to do is use its CV output 2 to send an envelope follower signal to our filter frequency. So let's do that right now. Let's take that CV2 and send that to CV3 input. And now we'll map that up in here. Take CV input 3 and map that to filter 3 frequency. So now let's just turn up our drum loop and make sure our envelope follower is working. Okay, it seems to be working. Remember that this envelope follower uses the global envelope, and so by changing a global envelope decay, that's essentially the same thing as the release parameter on the envelope follower in the Pulveriser. All right, so it does seem to be working. So now we want to map up its rotaries to control the envelope follower effect. So first we'll just add an envelope follower depth. And we'll map that to rotary 1. And we'll do envelope follower release on the next one. So rotary 2 going to global envelope decay. All right, so let's just move all these Thors up so they're easily accessible. Kind of tidy up down there. And so we've got really everything we need here. We've got our envelope follower controls, our LFO controls, and our filter frequency controls, as well as our distortion and compression controls and more filter controls up here. So we've really accomplished pretty much everything I'd like to accomplish with this Pulveriser-esque combinator. We've got two more buttons here, or sorry, two more controls here, and the last chapter is going to wrap everything up and make use of those two controls. For our final rotary on this combinator, I'd like a wet-dry control. So I'll label that now and we'll create it. So we're going to use the cross-fading technique that I've showed you numerous times. And I'm going to go through it quickly here. So I'm going to add 2 line mixers. I'm going to take the output from the Thor and put that into our, actually let's do the second channel there. And then I need our dry mix to put in the first channel. And I've actually already got that split with Spider Audio. That's it. So I'll take that. And now I'll take its output and send it to the combinator outputs. Once again, I'm going through this fairly quickly. Email me if you have questions about crossfading, but I think everybody's experienced it a few times now with Wizardry. So now we'll get rotary 4, pan on channel 1 and 2, reverse them, and same thing on the next one. And you kind of get a sense once you've done this a few times, just by looking at these pan knobs move, that yeah, you didn't make any mistakes, because that's exactly what it's supposed to look like when you've done it properly. So let's hear our drum loop. Okay, so that works great. And that leaves us with just the final button here on the combinator. And what I'd like to try is to use this button as a signal path control. Currently, we have compression going to distortion and then going to filtering. The Pulveriser has a pretty neat switch on the bottom that lets you change things up. So what I'd like to do is something similar, and I'd like to let this button switch the signal path so filtering comes first, and then dirt, and then compression. So that's not a very easy thing to do, and we're going to have to do some fairly complex routing, but I think in the end it's worth it. It's a nice finishing touch to this combinator. So start by giving it a little bit of thought how you would change the signal path around completely. My best way to approach it is to add 3 more Thors, and we're going to add them one after the distortion device and one after the compression, and one after the filtering. So what these Thors are going to do is going to switch between 2 possible audio destinations. I'll show you how this works. Okay, so this is our filter. Currently, it's just sending to one place. It's sending to the crossfader. So what we want to do is instead send to this Thor. And now inside this Thor, we're going to take audio inputs 1 and 2 and send those to audio outputs 1 and 2. But we're also going to send audio 1 and 2 to 3 and 4 as well. And now we're going to actually make those connections. So in 1 and 2, that's sending to the crossfader as usual. 3 and 4 are going to send to the distortion. So by modulating these controls here and the depth of them, we'll be able to control whether the filter outputs as usual directly to the wet-dry crossfader, or whether it sends back into the distortion. So the distortion already has something input to it. So what we're going to do is create a spider audio merger, and we're going to take its current input and also our new Thor input and mix those together. So now what we need to do is use a button to scale these audio inputs. So let's add button 1 to all of them. Now we'll do 100 for 3 and 4, and we'll do negative 100 for 1 and 2. So that means when we press button 1, we'll activate audio outputs 3 and 4, and we'll deactivate audio outputs 1 and 2. So in that way, those are our two different signal paths, but that's just for the filter. Remember, sending the filter back into the distortion. Now we need to also change the distortion path so that it will go back into the compression. Okay, so what we can actually do, and I should have thought of first, is copy this Thor. So let's do that right now. Copy that device, or, well, we'll just duplicate it. Twice. Okay, now I'll just remove these other ones that I added in. Yeah, that's one. And that's the other one. You can tell this combinator started to get fairly complex. So, all right, let's drag this one down. And we'll put that one beneath the distortion. And we'll drag this one down and put it underneath the compression. Okay, so for the distortion, right now, it's being output into the filter. So instead, we're going to remove that and we're going to send it through this Thor that we've just duplicated. And then we're going to take its first audio outputs and send those back through the filter. And then audio output 3 and 4 are going to go into the compressor. So same as before, we're going to need to create another spider audio merger and splitter. And we're going to take the inputs from the compressor and we're going to merge them with 3 and 4 here and send that back through the compressor. Now, since we've already got this stuff set up from the duplicate device, we don't need to do anything else in it. So we can move on to the compression. And the compression is actually output from this mixer, remember, because there's two types of compression. So that's its output. And so instead of going into this spider audio, it's going to go into this Thor. And then from the Thor, it will go into the Spider Audio. And for its output 3 and 4, remember, this is going to be the last device in the chain. If we're going to go filter, distortion, compression, then it's going to be the last device. So its output 3 and 4 actually needs to go into the wet-dry crossfader. So we need to create one more Spider Audio. Please bear with me here. And we're going to take this, which was actually our wet mix, and we're going to merge it with 3 and 4 from right here. Actually, I had to pause right there and make some changes. I'm not sure I can go through exactly every step I had to do to complete the signal path there. It was pretty complicated. Basically, the problem was that even though I had reversed the signal flow, I needed to put the dry signal starting in the filter, and I had to remove the dry signal from starting in the compressor. So that required a little bit of extra wizardry, you might say, and I'm just not sure I could recreate that live. So you'll just have to bear with me and maybe look through the patch to see the extra steps that I took in the mod matrices and whatnot. But what I can show you here is finishing it up by mapping this button to button 1 on 1, 2, 3, 4, 5 Thors. So we'll map that here with button 4 going to button 1, and then on Thor 5. Okay, and then for Thor 5, we'll go button 1, going to the Thor button 1, and now what else do we have? 5 copy 2, and 3, and 5 copy. This is where it's nice if you've labeled things correctly and haven't really done such a great job this time around. So what do we have here? 5 copy 2. Get that one. And finally, there we are. So let's just make sure this is working. And let's give it a listen. Okay, so this is the standard signal path, or at least it should be. So we've got the compression. And then going into the filter, and then the crossfader. So that's standard. Now let's click the signal path. Okay, so we've got the filter. And we can add distortion after that. finally compress the result. Okay, so that is our effort at a Pulveriser-esque combinator. I hope you enjoyed this month's issue, and I hope you're looking forward to Reason 6 as much as I am, because I'm sure we're going to have lots to talk about and show you in the coming months using it. Thanks again for watching. I'm Jeremy Jansen. Cheers.